Hi there, this is Jacob Nash Engineering Lessons, and this is Unit 2.1, Lesson 10, on Standard 2.1.4, Vectors. So, first, you might notice a picture of a character from a movie called Despicable Me. You might know that movie. And that is the bad person on there that is named Vector. And you might think, oh, well, what's the point? Well, if you've ever noticed, he actually says what a vector means that we're going to talk about. I always forget you can't push the arrows at first. So first we need to know the symbols that will be used. This may not make any sense right now. That's okay. I'll explain more later, but you need to know what these variables mean just for now. F will be used for force. Fx will be used for the x component. Fy will be used for the y component. The Greek letter theta, that's lowercase, represents angle, and that E-looking thing that we've used before is the sum of. That's what that means, uppercase sigma. So here's what's going to always happen for the components, the x and y components. If they're in this region of the coordinate plane, then it's going to be upright, and x will be positive and y will be positive. If it's in the down right, then x will be positive and y will be negative. If it's in the up left, x will be negative and y will be positive. And if it's in the down left, they will both be negative. I'll explain more later. So, vectors introduction. A vector is, well, let me just show you this clip, because this is where he says what it means.
Go by the name of vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude.
Hopefully you could hear that. I don't know if the sound comes out, but even if you didn't, it says here, vector is a quantity represented with the arrow with direction and magnitude. So it basically just represents a certain direction and magnitude. I mean, that's just what I said. So like in this example, see, direction is to the upright and of magnitude of 6 newtons. And like I said, if it's in the upright, positive, positive. So both the x and y components would be positive. And if you were trying to find this angle, it would say theta, like we said before. Direction, well, you know what that is. That's just basically where it's pointing from the reference axis, which is these black lines. Magnitude, length of the segment. Sometimes the length of the segment can be represented, but it also might just say right there, and that's the force. Since, what the sense means is indicated by, it's basically indicated by the direction of the tip of the arrow. So it's kind of just the exact direction written out. Sorry, I forgot the closing parenthesis. What would be the direction, magnitude, and sense of the vector shown? No, don't want that. Okay, so the direction is, oh, well, it says right there. Let me move this stupid watermark. Direction is 28 degrees up from the positive x-axis. This is the positive x, this is the negative x, this is the positive y, and then this is the negative y. They all come together at this point 0, 0. And then, so it's 28 degrees up from the positive x-axis and 62 degrees right from the positive y-axis. You might say, hey, where'd you get that from? Well, this is 90 degrees. The whole thing's 90 degrees. So 90 minus 28 is 62. That's why this is 62. Then the magnitude is 6 newtons. It says that there. And the sense is up and to the right. That's all it is, up and to the right. Oh, yeah. Once again, up is positive, down is negative, left is negative, and down is positive. Oh, no. That is messed up. Sorry. Um, let me fix that. I don't know. I must have copied and pasted that and forgot to change it. It's right is positive, down is not positive. There. Sorry about that typo. Um, so, Sokotoa. If you watched my geometry videos, which maybe it's not that likely that you did, but there's Jacob Nash geometry lessons, JNGL. But if you watch those, you will know about Sokotoa. I was going to add a video clip of myself explaining it, but if you've been able to tell, I know about this, but I'm not an adult, so I had a kind of voice change in the last year, so that was kind of embarrassing because I sounded like a lot littler, but whatever. So that's why I didn't add the clip, but I can still explain it. So Sokotoa, you can separate that by SOH, CA, CAH, and TOA. It means sine, cos, and tangent. Sine, cosine, tangent. And the buttons on the calculator, if you've ever seen them, they're here. That's kind of blurry, but sine, cosine, tangent. They're represented by sin, cos, tan. That's what their abbreviation is. And basically, this is just a equation like Pythagorean theorem that means that you can just add lengths of a triangle to find something. So to find the sine of something, you take the opposite and divide it by the hypotenuse. The hypotenuse is always going to be the length that is longest and across from the right angle. So that's this. That's what that means. SOH, sine, opposite, hypotenuse. That's what that means. So here is the angle. Remember, it's represented by theta. From its perspective, this is the opposite angle because it's the opposite from it. This is the adjacent angle. Oh no, sorry about that. I'll shut that up. Sorry about that. I had an alarm going off. This is the adjacent side. But if we were talking about this angle, this would be the opposite and this would be the adjacent. So it has to be from the angle's perspective. That's why I drew this dotted line. Hopefully that makes sense. So if we were trying to find the sine, we would say whatever this is. So let's say this is 3, 4, 5. That's just a basic triangle. So 3 divided by 5. That's what we would do to find the sine of this angle. Or sorry, what am I saying? That's how you find the measure of it. The measure. I don't know what I was thinking. And then the cosine is the adjacent over the hypotenuse. So that would be 4 divided by 5 if this was 3, 4, 5. And then tangent is opposite over adjacent. That would be 3 over 4. So that's what that is. I'll explain more about that in activity 2.1.4. Pythagorean theorem. I mentioned this earlier. Hopefully you know what this is. I think you probably would know what this is because it's explained in early middle school, late middle school, and then early high school also. If you took geometry or algebra, you've known this, and I think probably anyone taking this course has taken one or both of those. So the equation is a squared plus b squared equals c squared. So that just means you take a side, you add it, you square, and then you add to a side, you square that, and then it should equal that side squared. So c is always going to be the hypotenuse, which is across from the right angle, and a and b can be changed. That's the commutative property. So you see A or B. It doesn't matter which one. It can be either, and it won't change the answer. So this is the end of the video. Thank you for watching. Oh, I forgot to close parenthesis again. Um, watch how to complete activity 2.1.4 and the lesson 2 playlist. That will be lesson 10, and it's going to be coming up. So thank you for watching, and see that video.